locally. Good evening, heroes and heroines, and welcome to episode 216 of Practising Programming in C, in which we're going to be doing some more stuff on Cinera, and a very special hello to Daughter, who's already here and raring to go. So let's go. Where we're up to is we're doing the add, move, and del functionality for the database. So our test case here is generating the database containing this project and then removing this project from the configuration and trying to get that deletion to actually get through to the database. So let us do that. Let's try and remember how we do all the actual stuff. So we need to delete this. We need to delete this. We need to run this. Yeah, and that should, we just save that, so that should get the something project in. So there's all our stuff. We now need to comment out this and run this under the debugger. Yeah, I did actually mean to give myself some places to break actually, so let's just do that. So here's syncdb. Let's give ourselves a break here. It's literally going to be places where I'm going to put breakpoints. I want to see if I get to there. I want to see if I get to here. And I want to see if I get down to this area here. Similarly, I want to see in this function up here the same thing. I want to see what pace. I'm going to put in like 6 breakpoints. I think that's a reasonable way of doing it, because when I'm out there, I'm going to have all the information available to me that these functions actually have, at least at this point in the scopes. So that's what I wanted. We haven't done anything here, have we? So we can just do this. What's this? That's something specifically to do with code 82. In Snapchat into HTML. Yeah, I think this is stale, kind of. Let's leave it though, because yeah, let us leave it, because it Snapchats them into HTML. This whole stuff that we're doing here is supposed to be fixing up landmarks, so it's possible that we're gonna want to check this kind of stuff, essentially, because basically you can see here what this is doing is it's going through all the landmarks, it's reading in the landmark, right? If entry index is that, else that, and then what it does, it does locate entry, and this locate entry thing uses the actual landmarks, project index, and entry index. Okay, and these very things here are what we want to be making sure that we're fixing up. But it's actually just the project index is what we want to be fixing up. So we probably will actually want to test that. So those are the ones we wanted. And we have hit a breakpoint in here. So what have we got? So SI is that. Oh, sorry. It's a child count 0. Right. Okay. So what's S child? Right. It's something. Perfect. So this is the case that we're trying to talk about. Yeah, it's in here. So it's within sync projects. I see. So basically, my suggestion here, we've got to something. I want to delete the project something, which is exactly what it's going to be trying to do. So I think all we need to do is, do we have the accumulator at this point? Is it under G? Yeah, we do. So we're currently looking at generation 2. We're currently looking at generation 2. No, the ads are indexed. So we're looking at generation 2, and with 0 entries. Well, we've accumulated 0 entries in generation 2, right? So that should mean, shouldn't it, that something is the 0th entry in generation 2, shouldn't it? And I reckon it will be. I think I have this, don't I? No. What do I have? Do we have the okay, so we have the config. Right. I guess we can't necessarily actually talk about this very sensibly, because we don't actually know whose child we're talking about. All we know is that we're talking about a generation 2 person. So I mean, although I can kind of go like this. It doesn't make any sense as to well, actually, I suppose technically, because these are the 0th ones, we kind of can say, yeah, if this person here, like if the first child, well, it's actually this person's child, isn't it? It's not. Oh, of course it's not. Yeah. So we can't, right, because it's part of bitwise, right? Where's that? Yeah, it's in bitwise and in bitwise. So we don't have a sensible way of actually determining where we're up to. Determining if that's the right value. But we can kind of look through it here and eyeball it. So you can see 0th generation, first generation, first generation, first. 0th generation for this guy. And then first generation. And then second generation for something. Right. So the information that we've got there is that something will have been stored as a generation 2 index 0, right? Which is exactly what we've seen from the accumulator, wasn't it? Right, we're looking in the generation 2. I guess also, instead of using 2, I could also sort of say the current generation. Right. So that is all tallying up perfectly well. So all this is telling me is that for the accumulator, So I propose what you do is this. Delete project, you pass the... You can probably just pass like a project index straight up. That's simply, it's the generation number and the index of the project. Right. And then what you do is you remove that person. You remove, so you've got your projects array. Projects block, sorry. Should just be below this, shouldn't it? Something, yeah. So by the way that we're laying out this whole stuff, we can get to here by using the project index. And just skip that stuff. We also need to make sure that we delete this person, decrement the entry, the project count of this person's parent, wherever that is. Where is it? 10. So I believe the parent just comes straight in, doesn't it? Yeah, the DB header project. So the S is what we're talking about. We want to make sure that we decrement the... Does that sound right? Vex. I haven't... Was that the link that you did? The GIST? I haven't checked it out yet. I haven't checked out like GIST at least. Vex. What that could be referring to. It could be a tech type of thing. A vector-based tech-like. I wonder. So yeah. Child count of 1, yeah. No, I haven't. Should actually make a note, honestly, just so I don't lose it in the stuff. Is that the same link? Oh no, they're different. There you go. I'm not sure of the capitalization, by the way, daughter, because Twitch doesn't correctly get the capitalization coming through. Civil market language. Yeah, so basically, we are going to have the parent, right? So all you do is to delete the project, you pass the parent, you pass it doesn't even need to be the generations even, does it? As I was just saying, all it needs to be is the actual project index. Could we use the actual full generations for something? The thing about the generations is that we're accumulating into it. Now, what we're about to do, there's 2 generations. And there's no entries in this current generation, right? Because we are the 0th. So we don't even need to modify this, which is pretty interesting. there could have been the option like you pass the generations, and you decrement the something or other of something. Yeah, I mean, even if you've got later generations, like even if there's like a generation 3 thing, because we're gonna have to delete ourselves and all of our children. Even doing that, we're not going to have any generation 3 people to talk about. So even those people will need to decrement. If you're wondering why I'm using those, because he's not gonna. No, I was wondering if it's lowercase, because I actually use. I mean, like if I type in the chat, how is my username capitalized? It should have a capital M. And I definitely remember that Simpalexy's username has like capital SIM at least. Upcase, yeah. Yeah, so I have a bit of a different convention. So yeah, I do some weird things. Like in the Arch Linux forum, like my I think my username is this. I think that's my username in the Arch Linux forum. Sometimes I use if I'm using like the full Mibla.carpio thing, I use that. But usually, if I can use just Mibla on its own, then I use like the full use the I capitalize it like that. So yeah, our delete project function. Should we just do this? Do a delete project. It needs to take additionally I mean, it's taking the generations, but it doesn't need to necessarily take that. It does need to take the header to the parent. And this delete project, I think I'm going to call it delete child project top level. Oh no, I'm not. No, that's garbage. Because this person's parent isn't the top level. This is just a regular DB header project. So yeah, delete. I'm gonna call it delete child project. Yeah, I call it delete child project only so that, well, I mean, always, whenever you delete a child, you always need to actually decrement their parents' count. So yeah, let's just stick with this. So we're deleting that. It's a child, and then let's say we can just pass the G actually, because it'll just say people outside working doing any garbage. I think I'll about PC names and user locals, or at least new ones. Tell you what, actually, one complete violation of what I just said. Although I don't actually use Mibler for my login, you can see that my actual username is Matt. So I do keep that as short as the lowercase. Yeah, like I would never have picked that. So I guess, yeah, I guess for logging into the computer, I always use lowercase for that. I think basically my kind of rule is how are you. I basically think like how are you mostly identified in a given on a given website. So if on a website you are identified by your username, like there's no way to put like your real name or something else, then I would try and use capitalization and spaces and stuff like that. Listen, I'm pretty sure that I'm not going to be able to find it, but let's have a look. Oh, by the way, I did try the past menu thing just before launching the stream, which was really cool. Yeah, it does look sweet. And I might bind it to a key, actually. You just whack the key, find your thing, type your password, type your main master password in, and then you're away. Really? So what am I called then? Ah. Please wait for 54 seconds and try searching again. I mean, I suppose we could like crowdsource this search, couldn't we? How does it know who I am? Oh, fancy. Clever, clever, clever. Pretty sure I do actually at least have a username on this thing. Don't know, don't care. It's not super important. So let's ignore it for now. There's definitely somewhere that I did use Del Carpio as my username though. And basically the thinking was that on that particular website, that's just the name that was being used. IP, yeah, probably. So, like, whenever you're kind of mentioned on the site, they're using your username. I think Mibbler might have been taken. It was either taken or it was too short. Like, the username had to be more than 5 characters or something. But yeah, here we go. So delete project. So that's kind of like the parents. Yeah, I guess parent-child, isn't it, really? And it can take the generations. Right. Then what you do is you get the... So we want to get a product index. Hang on. I mean, you just get current. What this is basically going to do is it's just going to do what I just did manually. It's going to perform this. It's going to just return. It's going to return like current generation and that. So let's just do the function. I do have that actually, don't I? Yeah, generation index. And let's also double check that I'm actually using that somewhere. Yeah, I'm actually not using it. Yeah, I might be better off using the DB product index actually. For some reason I do still have this product index sitting around. That little structure. Can I get there? I mean this guy. Can I just delete that and still build? So it's passing the S, wasn't it? Ah, this is the top level one, isn't it? So I do need the different function for this guy. Because this deletion down here, you know, this S parent is actually the DB block, yeah. So that's what we do. We don't have that function yet. So it's going to be taking the same stuff apart from this, which is going to be DB block projects. Come to know. Oh, nice one. I was really want to see it. Cool. So DB product index. This is going to be something. Get something. And it's going to take the generations. And it's basically just going to be so how do you describe that? It's like the get accumulator state, or get the I mean, it's getting the latest. So we're actually returning a DB product index. Get product index. Get current product index. Right? Why not? Sounds good enough to me. Because we've accumulated. Basically, the thinking is that we've accumulated all of our products into the generations, and we're getting the product index of the current generation. So where we're up to in the actual accumulating process, that's what we're trying to get out of it. Oh, I've already done it. Oh. Well, there we go then. That was a good name for the function, because that's what we called it originally. Yeah. Now, that's so funny. Let's just make sure that it's doing the right thing. Now the thing is actually, it's returning the the index of that -1, which isn't actually. How is this being used? I mean, if it's only been called there, yeah, it is. So it's only been called there, which means it's pretty cheesy. But you can just do like that, and then you don't decrement by 0, don't decrement by 1, and then you've still got the right stuff, right? That sounds reasonable to me. Let's go with it. So we've got the we've got the header, we've got the parent, we've got the child, we've now got the current index. We need to accumulate the generations for the current project. And this was project generations. What's it saying? Evaluate initializer. It takes the project generations and DB header project P. Is that always going to work? I think that should always work because it's always going to be, the child is always going to be a DB project header. Oh, it's a void. I see. So what? Accumulator. So. Oh right. Okay, yeah. So you don't do it like that. You actually do. So you initialize it based on that information, and then you accumulate into that. So the idea is, having done that, we're then going to have to can I just print the index? I'd just like to take a quick gander at that to see what we're actually being producing. Right, so we're at least stomping that warning. I think we actually need to. If I just reload, where are we breaking? Yeah, you see, when you reload, it just breaks all your breaks. Breaks all your stuff. You just can't fix up your stuff, which is very unfortunate. I should mention, by the way, that Electrolane are currently going absolutely bananas with this track, business or otherwise. Okay. So, yeah, CG and then break here is a thing. So we've got to here. Step into delete projects. And let's take a look at this index. Sorry. Yeah, I think I knew that was going to be right, didn't I? It's the child accumulator that I want to be looking at. So there's two, the current generation is 2. There were 3 generations. So let's take a look at our entries in generation. We should find that there's 0, 0, and then something, shouldn't we? Yeah, and that's exactly what we do find. And then there's like, I guess because there's 3 generations. Yeah, because there's 3 generations, we know there's nothing more. We could expand our test, actually. Let's expand our test. Just bear with me, because I do want to get this right. Right. So I'm going to be, this is our test stuff. What I'm going to try and do now, this is looking correct according to what this was saying previously. What I'd like to do is to do the same thing. Oh, dude, okay. I hope you get a better internet connection at some point. You'll be able to find the VOD on YouTube as well if you fancy. Yeah, I'm going to generate this whole thing and then comment out the whole thing again. And what I should be expecting to see is that there's an extra count, and also that the 4th generation has or rather the 3rd, yeah, the 3rd generation will have a count of 1. Right, that's what I'm expecting. Let's do it. No, let's actually just run it. Run it once, and let's run it again. Oh yeah, I forgot to delete the thing. Alright, so there we go, there's something gone. And we're going to here, perfect. Not in sync, we don't care about being in sync. We do not want to be in sync the band at all. So, now what have we got? There's 4 generations. There's no people in that either. There should be someone in this, and there should be someone in this. Perfect. Nailed it. So that's all working exactly as I'd hope it would work. So, having established that, what do we have? We've got our child. We can get so we know where the child is located in our thing. We know who our parent is, so we know that we can actually decrement their child's thing. And we can just totally do that, can't we? Right. So So that stuff up there has to happen. We're decorating the child count. And we know that we're going to have to write out past the... We're going to have to write out up to the C, right? Then what we do is we say end of C is going to be just, it's just going to be a pointer that's after it. I think skip produce and children just returns a void, doesn't it? Yeah, so we don't even care what that is. So you can just say it's a car style. Right. So you're basically going to be writing out, so you've decremented that, you write out up to C, you get where the after child is, and then you want to write out from the child to the end of the file. Oh, actually, that's not right. We do also need to delete the HTML files of all the entries in C and its children. So, yeah, we do need to do that. So I suppose, actually, what you could do is, instead of doing a skip product and children, you could say that you can just say delete entries of product and children and make that return the pointer. make that return the pointer in the database that's after there. Right. Then having deleted that project, I guess you could do it in one fell swoop because you're literally just deleting. You still got the buffer of all the stuff. So you've got the buffer, the only thing you're doing is omitting some of the stuff from the actual write out. You then locate the assets block. Sorry. Right. And then you need to get to the... You need to go over each asset and say delete the landmarks associated with this asset. Delete the landmarks for this asset. Associated with this asset for this index. Is that right? You also do need to do it for the child accumulator. It also needs to do its stuff, doesn't it? Child accumulator contained 0011. So we know that we should be deleting we've got the actual project generations here, haven't we? Up to now, we've accumulated no other people into the other generations. So I think we should be entitled to just say that for the entirety of the child accumulator, any generations above the actual the incoming overall accumulators generation count, we can just freely offset anyone in the generations that are following us, can't we? I suppose also let's just say insert index. Or let's what are we actually doing here? We are, well, let's just write it. Oh yeah, actually you can't do that because you actually need to skip them. Yeah. So the first asset. So I suppose actually we do this, and each time through the loop you just set the asset to be equal to a skip an asset. Right, that does exist, doesn't it? Yeah. What's project range? So yeah, landmark range. We pass it an asset. So that's taking the current project index. Is that sufficient? Shouldn't it be taking the entire... Oh no, the current project index is actually both parts, isn't it? Isn't it? Yeah, it is. It's the generation and the index, so that's perfect. Determine project landmark's range. And it's the incoming index. Right, that should all be working, shouldn't it? Yeah, the only problem is it's not used. These guys aren't used. Where, what's that saying? After child. After child. So that's to do with right. That's just giving us the pointer after the deed, so we know where we're actually writing from, up to somewhere else. So basically, what this is saying here is delete all of the projects, or what we're going to do is delete all the landmarks yeah, we need to do it also for the all the children too, right? Because we're going to be determining these landmarks here. I'm going to do a function here. For each asset, it's going to be delete the so we've got 1 and 1. Current generation is 2. I think that's right. And then we need to pass the asset itself, obviously. We need to pass the child accumulator. And we surely also need to know so the actual information that we need is not, I don't think, 0011, right? I think the actual information that we need is basically the child accumulator plus the project generations, right? So we basically accumulate the project indices. Yeah, I mean, in some ways it sort of seems like, doesn't it? It seems like you want to be almost copying the accumulator, doesn't it? Because what other use? Let's keep them separate actually for now, because there might be a reason for, you know, needing them separately. What was it? DB header asset, I think. This is going to be like the main accumulator. And the local accumulator. Bit of a weird way of doing it. Is that what we even passed? Yeah, it is. Now, where's the index coming from? Let's get it. It's from the. I think it's also worth bearing in mind, as I did say before, all we're doing here is deleting. So we don't need to actually read the file back in to the buffer until we're done. Don't think. You can just continue to delete the whole lot. And then, basically just tweaking just decrementing the project counts, right? Or the child counts, whatever they're called. Yeah, you just decrement the child count, write the stuff out to file, decrement, in the cases of the landmarks, decrement project indices, write all the stuff out, and then finally at the very end just close the file and read it back in. Cycle the file. I think that sounds right. Oh, it's just a DB asset, isn't it? So there, we need the get current project index. So that's from the main accumulator. Let's just at least do it for one of them first, and let's think about getting the children involved. So, delete my limits of projects. So at this point, we're going over all the assets. So we're not going to modify the assets, the count of the assets block, right? That's not going to be a thing that we do. So the question is, how do we know where we're up to? because the asset itself, for each asset, we're going to have to write out. We're going to have to decrement the landmark count. Modify landmarks and then write out remaining landmarks. So I think we should just assume that when we get in here, that the first thing we do right. So we know we need to do that. First of all, we know we need to, having done that, write out the asset from the asset to the first landmark. Right. And then we skip past those landmarks. And then for all the remaining landmarks in our generation, decrement their index, right? And then write out the range of the landmarks. Does that sound right? It's also worth bearing in mind that the landmarks are also sorted by their project index and their entry index. So it's all sorted, meaning that anybody who should come before us will get written out when we actually write out up to the first landmark in this range. So yeah, it seems like what you do is you write out to that guy, and then you skip past the landmark range that we've determined here, and then you load in all the landmarks in our generation, decrementing them. And then once you've done that, you then go on and sort of see, are there any children to deal with? We're still talking about the same asset, but what we're now talking about is a different index, right? So we'd need to determine the project's landmark range of those indices, wherever that is. Get a comforted index from the main accumulator, but we'll have to somehow figure out how we do that. Let's just get some of this going. What we're talking about here is like the right past assets landmark header. What does this do? How does it know what it's doing? Where's the open thing? There it is. It's the DB metadata file path is what we're talking about. Right. We've got some of it going. So it needs to open that. We've decremented the P by the child count. And we need to write out up to C. So you can just cast that, can't you? What is it? Beyond Streetstrip cause frustration. So it's DB metadata. We're writing out from there up to right, is that at least right? think it might be. Right, so you write it up to C. We do also need to decrement the deleted HTML files. But there's after child, right? I suppose let's do a bytes written variable as well, just so we know where we're up to. Or bytes through file. Bytes through buffer. Because it's not necessarily that, is it? So the after child is going to be the skip throws and children. We've still got C. So then we need to position our person after the assets block, which is going to be at the first asset. So we basically need to write out to the first asset. Right? Does that sound right? Because we're written up to that child. We need to skip that child. Bytes through buffer. From location plus bytes through buffer up to that, take away the also, let's just get a buffer out of this because we're going to be writing, we're going to be using it. I gotta be right. Sorry. Yeah, it's actually down here, isn't it? I need to do it. So you've located that asset. Right, so you've got the past the assets block is essentially where we need to be. I suppose let's make that more explicit. Well, I think that's kind of right. And then we're going to write from the location plus the bytes through buffer up to the after assets block. Now there's surely a better way of doing this. So we've got the location plus the bytes through the buffer. We've got the after assets block somewhere. After assets block. So trying to I think I should work this out in a different way actually. So rather than saying car after assets block, let's actually talk about byte offset. Wouldn't that be more sensible? Sorry. Right, so you know where that is in relation to the start of the buffer. Does that sound right? C takeaway B. Let's do a U for that as well. It's getting a bit messy, isn't it? Where's the F open? So that's happening there. Bytes through buffer is set up there. Do slightly different. Let's just get ourselves going a bit more sensibly. So decrementing that. So we've got your handle bytes through buffer, and the B is that. Right, you want to first of all decrement the child counts for the P header. We know that the child comes after the P header, so we get the child byte, figure out where that is in relation to the location. We write that. So the very first thing we're writing is the thing. We're going to write from the B location to the child byte. And then we've got through the buffer by the child byte. I think that sounds a bit more reasonable. bit more followable. So we still need to delete the HTML files. So after child is there, byte stage buffer is here. Now, with that far through the buffer, what I was saying was, let's try and do the same thing. So we want to figure out the U8, the assets block byte. So it's like the first asset byte. Is that. And then we're going to write out. We're always going to be doing byte stage buffer. I mean, I guess. It's going to be 0, which is fine. Write out from that. Where's it? Have we done the F right yet? Oh, that's what I'm doing next. Now, is that all it is? Just want to make sure I'm writing out all the right stuff. So the B location is right at the start, plus the bytes through the buffer. I want to write out from the first asset byte. Well, to write out the amount of stuff between the first asset byte and the bytes through the buffer. So that should give us that, shouldn't it? And then having done that, you want to increment by that amount. So yeah, I think this is right. Is it building? So having done that, we're now in the position to actually go through all our assets. Now surely we need to pass the bytes through buffer. You know, so that it can actually do some sensible stuff. It can continue to do the same stuff that we're doing here. Now, do you not think it would be nice if we actually kind of bundle this functionality up? What are these guys saying? I'm going to do that. I'm going to try and bundle it up. So it's taking the bytes through buffer, which it can itself increment. So yeah, I mean, I guess it's just taking voids, isn't it? Let's just make it do something. So it's like the start of buffer, isn't it? The B location is where it wants to be writing from. I mean, it's buffer, because this count is always going to be 1. I think. So the buffer size, so the bytes through buffer. Need to take that as a pointer. And then the actual file handle. And then finally the new stuff. Right. Like, is this going to be at all helpful for me? So what we're talking about is writing right up to. Right. Well, let's just say pointer. Right from byte to pointer. No, I feel like I should put it the other way around. So I'm grouping these dudes together. Also, for that matter, we could just pass the the DB metadata, right? So it's taking like a file buffer. Oh, it's just a file. Oh, also this guy's a signposted file, isn't it? Well, hang on a second. That doesn't matter, does it? Because you just pass the actual file. That's how you do that one. Yeah, see, decrement that thing. Right from byte to pointer. Right, and then that's performed this stuff here. So skipping that child. And we've got the asset, and then what we're trying to do is write from byte to pointer. We're always passing that byte, and then we're writing up to the asset, and then we should be away, shouldn't we? Okay. Now I hope that has just helped and not actually just obfuscated what's going on. So now what do we have? Delete landmarks of project. So this guy is going to have the assets available. Yeah, like I say, it's going to need the byte available so we can modify it. Probably. I mean, there might be another way of doing it, but let's make it take the byte. So I think we can guarantee that we've written out enough of the stuff. We've written out what we need to have written out. So we just continue to do write from byte to pointer, don't we? And it's only when we omit stuff that we ourselves just increment the bytes through buffer. We don't have it. Oh, it's okay. So there's the first landmark. We now want to just straight up get a pointer that is at the lower end of the landmark range. Is it first or start? Alright, so that's pissing our dude here. So now what I suggest we need to do, because we've decremented our landmark count. Can you just do this actually? It's pretty cheeky if you can just do that and get it right. It's a bit cheesy because it's a global, but whatever. So we're writing up to the actual landmark. Right. And they want to say the bytes buffer we need to plus equal to the size of a landmark times the right? So we're going to increment past those dudes. And then what we need to do is we need to say for each landmark. So let's save off the existing landmark count first of all. So this isn't going to be right first of all, because it's going to get through too many people. It's going to go through all of the generations. But yeah, let's at least do this first, knowing that we we could just say, because we haven't moved that landmark, have we? Well, hang on a second. Yeah, we could do this, couldn't we? Bites buffers there. Right, so let's stuff that person after the range, because then we can just sort of say if that equals the index generation. Is that right? If that is equal to the index generation, then what you say is that the landmarks project index. You just decrement it. Right. I think that's all you do. I'm going to do this manually because I'm not sure how this is going to play out. In fact, I don't think you can, because I'm not writing it from the buffer. Well, I kind of am actually, aren't I? Because this is actually this is in the buffer, so I suppose I sort of am. Write from byte to pointer. Yeah, I guess I could actually, couldn't I? Write from buffer to pointer. No, that's not going to include the landmark. So let's just write out this, write out the landmark itself. To the file. Right, and then just manually increment the bytes through file buffer. So essentially it's going to be going through every single landmark. If the landmark is the same generation as us, then decrement the project index of that landmark. And then we want to increment the landmark. So I guess. So we're doing that for each asset. We should have got through all of the skip asset is still talking about the thing in the actual buffer, which is still valid. Oh no, it's not. So that's the problem. So I think we could probably actually use the byte through buffer, couldn't we? Right. This is getting super cheesy now, but yeah, I can't actually do this computation, can I? Now, don't try this at home, folks, I guess is what I'd say about that. Yeah, I mean, I guess I could make... I could make this return of something, couldn't I? Do I want to do that? It's a bit weird because this isn't even taking the DB metadata. I mean, yeah, you can't actually quite... Well, I mean, you kind of could actually, couldn't you? I don't like it. I was going to say you could just do this, and then you put sorted, but I'm not. I think I'm going to do it differently. So yeah, we're incrementing the byte all the time. We're getting through all of the assets. Then I think by this point we should just be able to say, write out the rest of the file. I mean, right from byte to end. Oh, bytes 3 buffer is what I actually want to be talking about. I guess we can take that as a pointer so we can modify it. Is that all right? Is it F buffer? Yeah, I think it is. Oh, yeah, it's just a buffer actually, wasn't it? Wait, what is he taking? He's taking a file. Okay. Alright. So there he's taking a file. So right from byte to pointer, right from byte to end. And then cycle signposted file. Right. Now, if I'm not much mistaken, that should do most of it, I think, shouldn't it? So we've got a stored child count. I think the S is going to have to be fixed up, actually, isn't it? Right. Because when we pass this S here to the DB header project, we're actually modifying that P child count. So it comes into the P. DB header project. Parent. This cycle signposted file. So just so we've got a bit of a more flexible way of doing this. Right, and after cycling that signposted file, let's just say that what we're going to be doing is P. We're going to have to return it, actually. The new header. Right. Does that sound fair? Right. So that then, I hope that's not going to screw us over when we actually need to descend into children. How? How does it not know that we've returned before those lines? Guess it just doesn't know. It just doesn't know. Alright, so we worked through that really, really carefully. And we've just killed something. So that's an unused variable now. Or is, right. What do I mean, all right? What do I mean, oh right? The index generation. I've passed the child accumulator to delete landmarks of projects and children. Oh right, yeah, and delete landmarks of projects and children actually itself does this same call again, doesn't it? Yeah. All right, so I can believe that that's an okay thing to do at the moment. So we still haven't deleted the HTML files, right? So that's we know that that's happening, not happening rather, and we also know that we're not descending into the local accumulator, correctly deleting all of those people and offsetting those dudes. But we are decrementing the project generations. Sorry, we're decrementing the project indices of everybody who's in our generation. So should we just run it and see what goes on? Calling this in one place. Yeah, that sounds about right. I'm just going to take a couple of minutes and then we're gonna run it. Alright, let's run it. See, I've dropped a couple of hundred frames there. Don't exactly know what was going on there. So I apologise if the stream is all out of sync, because I've spotted that can happen. If you drop frames, the stream goes out of sync with the video and the audio's not synced up, if you can even tell. But I've recorded it offline anyway, so the recording itself will have the stuff in sync. At least it should do. So, moment of truth. Cinera.conf. We're off. Bitwise. This is our test project. Right. So we need to first of all delete that. Delete this. Well, I don't think we should even touch our actual code this time around. Now we want to delete this. Oh. Yeah. This isn't going to actually be right because we don't actually handle this case. Because this person's got a child, so we need to actually delete this. Let's try again. All right. Oh, and also this whole thing was actually. We're getting there. Right. Now we could just run it and hope for the best. Should we just do that? Let's do it. Right, perfect. Just got to delete. We've got an error in delete project. Pointing to the 0 page. Oh, interesting. 10. So that's talking about the assets block. So that deletes asset. Now, yeah, assets block, I see. So that is a key, that's acquired out here, yeah. Now, I suppose rather than using the assets block count, could we use the thing? We could just do that. Do we need anything else? Don't think we do. Could that be a problem when we come out of there, though? So we're going to be doing it for all of the people, but only operating on S. So yeah, I guess that was all we needed to fix up in that particular instance. Let's try again. Oh, we need to change the config. So now we've got the same error, haven't we? So this doesn't like this. Was that the, oh! Buffer doesn't exist. So what was I trying to do? 10. Right, okay, so that just didn't fix it. Yeah, of course it won't. Cycle signposted file has lost its thing. I guess my question though is, shouldn't the assets block have remained untouched? Right, because we haven't actually. Yeah, this shouldn't have fixed anything, should it? We've got the assets block out here. We located that block. I mean, I guess it's possible that we didn't locate it. We can return 0. So this is a recursive call to sync projects. Delete projects is only called the once. Now, sync projects. Sync projects doesn't write anything, does it? So it might actually, mightn't it? When it does this insert project into DB, although it shouldn't have to do that because we're not even inserting anyone this time around. Although we might have hit that. So did I just delete something? Yeah, I did delete something. So 10.184 would be the actual line. So there was this call to delete, of course, because this is in the call that we have. assets box. There's apparently pointed to the 0 page. Oh, you see, I mean, that's the only pointer that's going on, isn't it? So we delete landmarks and project. So it's F writing out to that handle. But like I say, the buffer remains untouched. We have judiciously set the skip to the next asset in this manner. Should we just step through and just see exactly what it's doing? I think that's our best option. I just can't really see exactly what could be going wrong there. CBGBs. So what have we been presented with? Our parent is bitwise. Our cells is something, is it? Yeah. And the generations are going to be something as well. So it's 0 bytes through the through the buffer. So the byte, is it? Oh, that's the location of the pointer, right? Okay, that's fine. Yeah, and then we're going to write out from the buffer location plus the bytes through the buffer, which is coming in as 0, up to that byte, take away the bytes through the buffer. Right, that's at size 1 and then F handle. And then we're going to increment the bytes through the buffer by the byte. Plus equal to byte, take away that. Which should leave us actually at the byte, shouldn't it? So after doing that, the bytes through the buffer should be equal to that, shouldn't it? Yeah. That won't be the case when the incoming bytes through the buffer is not 0. The after child is going to be that. Now, that should be after child take away the byte, shouldn't it? Shouldn't it? Maybe. Not 100% sure about that. But let's carry on. This is 7,000 something. And now it's another 400 or so on. Yeah, I can buy that. It's the size of a project. About. So, that failed. What's the locate block supposed to be doing? Let's play it all again and actually get ourselves into that test, into that function. So yeah, you're going to just witness me just fastidiously going through this stuff, by the way. I suppose before we even open this, we can run to here, and I think before we even open this file, we should be able to look at it, shouldn't we? There's our assets block. So let's see what locate block is doing. B asset is definitely what we're trying to do. I mean, I can buy that. Skip block. Oh, hold on a second. Ah. Hang on. Oh, we've already decremented that. That's unfortunate, isn't it? Because this locate block is going to have to skip the projects block, but we've just decremented we've decremented this person here. So I think we need to actually locate the block before we do this, because otherwise this ain't gonna find anyone. That's unfortunate. Yeah, I mean, it kind of argues for, doesn't it? It argues for not actually modifying stuff in the buffer itself, right? So you just let the buffer sit as it is, and you actually dereference people. Dereference people, modify them. The only problem with doing that, though, is that you can't really do the write from byte to pointer thing so readily, can you? Because if you're just dereferencing, if you're dereferencing and then modifying this child count here, then you sort of have to do it a bit more piecemeal, right? You'd have to write from byte to pointer, and the pointer would have to be the P, right? Actually, maybe that wouldn't be such a problem. You write from P, and then you just increment. Yeah, you just increment the byte counter by the size of the P, and then write out from that byte up to the C as you want. So maybe that isn't so bad actually. Does that make any sense? Basically, what I'm saying is this P here is pointing directly into the metadata buffer file, metadata file buffer, right? Which we're then writing out here. But then when we come down to this locate block function, I'll continue to step through it to actually illustrate what's going on. But what's first going to happen is, in this locate block, the first is going to check the first into the first block. It's going to be not asset, which is what we're trying to find. It's going to be project, so it's going to have to skip that block. Let's just do it. Right, skip block. So we've got the first in. So what is it? Is it a proj? Yes, it is a proj. I know it's proj. So we're going to skip that project block. Right. Now remember this P child count here. A P is a DB header project, so it's not going to be anything to do with the block count. We're going to get into here. It's going to be in skip project and children. Right, and this is going to happen recursively. Now, do I have anything out here? Yeah, I'm not sure I can really, like I don't have remedy BG's ability to look up into previous scopes, unfortunately. So I can't actually show the state before doing the decrement. DB header project. I suppose we kind of know what we're talking about though, don't we? We know that we're talking about the bitwise project, right? So we should be able to get through into here one more time. Basically, see this child count here? We're going to have, see this bitwise, we're going to have bitwise and then this inner bitwise person, right? It would previously have had a child count of 1. It's now going to have a child count of 0 because we just decremented that. And then this person is going to fail to actually get that. We don't need to go to here because we're talking about hero. Going to go through 5 of them. Yeah. Now this is probably going to be bitwise, isn't it? Yeah. So if we step into here, so we skip past bitwise itself. I'm looking at its first children. It's probably bitwise, isn't it? Yeah. So now this guy actually has a child count of 0. Right. Let's step in. And now it's looking at something. Yeah, I mean that is in the metadata thing, isn't it? Let's just keep going. So it's going to return something. Is that right? I'm not exactly sure what that's supposed to be saying. Can I just cast this to a car star? How do you do this? Could do with having like a thing. But let's just see what this actually does. So apparently it's trying to skip block. Let's step into this. Is it a B proj? No. Is it a B asset? It's not. So yeah, it just hasn't. Yeah, it's just not managed to get through the stuff properly. Basically, when we got through to this second time round, locate block, we should have found that the person we were talking about was the actual assets block. We didn't manage to actually eyeball it, but it doesn't matter. Right, and then we're going to write what have we written so far. Yeah, we want to write out from the byte to the P first, and then we want to write. I mean, I guess we could just kind of do this. We don't really care about that. In fact, now that I say it, we definitely do care about that because we need to keep that the same. So we've got a new parent, dereferencing the P, and we're then decrementing the child count of the new parent. We then want to write out, yeah, just a straight up write out. So it's a DB, sorry, it's and then we want to increment the byte. And then we want to do another write from byte to pointer. We can actually grab the stuff. This time going to the C, right? So we should be writing out from after the parent up to the C. And then I think everything from there should be okay. See the child count there? That's the thing that we were going to decrement, which we are going to decrement. So we're writing out the new parent, incrementing the byte past that header, and then we're going to write out from that byte to the C. And then we're going to skip past that child, incrementing the byte. Yeah, and I think C at this, as I was saying, it's byte after child takeaway byte itself should be okay to do there. Probably evaluates to basically the same thing. But now, if we just step over this, do we have the assets block? We do, perfect. The existing landmark count, so we are going to be modifying the asset, aren't we? Yeah, we're modifying the asset's landmark count. But my contention is that that is okay. Although now that I think about it, we could just use the same trick, couldn't we? You know, the trick that we just did of actually, well, it's not a trick, but just not actually using this dude. We could actually retain the assets landmark count. Yeah, and if we do that, then we could also, where's that existing landmark count? It's in here, isn't it? Right, it's right of it. So the existing landmark count. So the existing landmark count is actually going to be the actual existing landmark count, because we're not going to actually modify this itself. That does sound reasonable to me. So I think I will do that. Let's just continue there, see what happens. So we've got a generation 2, index 1. Cool. Fine by me. Aha, segfault. Cool. Is that in? Determine project landmark range. Yeah, that's just probably a product of us having modified the asset landmark count. And then what we want to do is write from byte to pointer up to that asset. So you need a couple of these. We then f write the db, sorry, the new asset. One of them to the db metadata file handle. Increment the byte through buffer. Yeah, and then right after the landmark. So that means that this guy doesn't need to return anything. And this guy can just do a skip asset. Right. And it'll have the correct stuff. Yeah, we don't need to use that existing landmark count actually, because we're straight up storing it. We're straight up retaining it rather. Oh. Yeah, right. So these guys are actually going to have that project generation actually set to something else, aren't they? So, I think actually, rather than modifying those, we just always dereference the landmark and just work with a different landmark. I think that could have been getting in our way. Could it? In some ways you could sort of argue that it shouldn't have been actually, because we're talking about the second asset. Which means that we shouldn't have been talking about these modified assets at all, these modified landmarks at all. It's probably no bad thing to do what I'm doing though, which is dereferencing this landmark to get a new one that we write out. So that starts out at the... Yeah, I mean that could be wrong, couldn't it? Although I think we did see that the landmark seemed to be a reasonable value. Oh yeah, again that's that thing, that's C. After child. I don't think we get back into that loop, do we? Because we're always talking about just the delete projects. Yeah, so that's not an issue, I don't think. So yeah, that's still an asset. How's this that? Right. Cycle it. So what do we have? Should find the between hero and yeah, it's in bitwise, isn't it? So we don't see something. Definitely don't see something, which is bang on. Didn't see it at the start of bitwise or at the end. So yeah, something has disappeared. And everybody else has got written out. And here's our assets block. No idea if that's right. What's that returning? It thinks it's supposed to do that. Let's just let it do that then. Ah. S child is going to be out of date now. Oh, maybe not. How is that now out of date? What was that set to? The stored child is locate first child project. I mean, we might be able to see it, but this thing might actually crash. Yeah. I think at least we've got the deletion working, which I'm pretty satisfied that actually kind of is. Although we still need to do this, just sending it into the local arc. Correctly handed the deletion of that too. Well, I think we've at least got one layer of it happening. We've got the notion of dereferencing these guys and only writing out the modified, only writing out the new things that we've dereferenced. We haven't deleted the HTML files, so we do need to do that. But we need a way to retain that pointer. So I think we'll start the next stream with that. That was the failure on 10. On 10, where's that? 10186. Yeah, that's going to be our task for tomorrow. I'm going to figure out that's the first thing, and then we can continue to actually handle the deletion of various people. And then once we've got the deletion down, we can figure out moving, rearranging people, inserting people, and all the rest of the stuff. So, thank you very much, heroes and heroines, for being here, for being beautiful, and most of all, for being connected. Until next time, farewell for now.